It came on when I joined the meeting, which was kind of weird. I can turn it off and then turn it back on again.
The caving face is 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes.
I've got the heater on.
We're just observers, these two little dots on the side of the mountain. And we watched and recorded the largest witness calving event ever caught on tape.
And it's just a case of being at the right place at the right time.
So how big was this calving event that we just looked at? We'll resort to some illustrations again to give you a sense of scale. It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical, miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
I haven't been able to do it. Between traveling and cloudy skies, I haven't been doing any observing for like months. Yeah. Looking forward to June. Hoping June will turn that around. And I did turn the
Is my mic live? We're going to wait another 5 minutes for people to show up, and then we'll start the show. What we're going to do is we're going to go through the slides. And I apologize to you for my slides not being as professional as Mark's, but my slide deck was an old deck. And then what we'll do is we'll go to the presentation. Expect the presentation to last about 1 hour, and then we'll have videos afterwards, like the ones you just saw. The video you just saw was a video from a presentation that I did about 4 years ago. And yeah, I've got similar videos to show you guys tonight. So it's a break. What's up?
Just working all the time.
Oh, you're not the only one.
Oh, I'm gonna, cut out
Are we? Can you mute me for a minute?
I can do it.
Okay.
cut out
Hello? Can people hear me? Hello? Okay, we have contact. We have about, let's see, about what? 20, 25 people here at the observatory. And how many do we have online now?
We have 16.
Okay, that's not bad. We're pushing like 40 some people. That's an acceptable meeting, especially for summertime, or hope to be summertime. My name is David Bishop. I am the Vice President of the Astronomy section of the Rochester Academy of Science. Our president is currently on the road from the Texas Star Party and is currently on his way home, and he won't be back for another couple of days. So I'm standing in his stead. Okay. Make sure my clicker works. Well, I got to move the mouse into the window and then use the clicker.
You have to actually click on the window in order to get it to get focus. So just click and now.
Okay. There we go. Announcements. Okay, here's our agenda. Welcome. Do we have any new members tonight? Any new members? Any people that haven't been here before? How about online? Alyssa? Hello?
Yeah. Yep. That's me. I'm new. New.
Okay. And I take it you heard about us through Devin?
Yes, sir.
Okay. Devin is also a new member here tonight. Devin, raise your hand. Devin is coming in as a spy from the Buffalo group. We welcome her. She's actually now a member of our group. Okay. First time at astronomy meeting. We just did that. Any observing recently? Bob.
Yeah, yesterday I got some images of that big sunspot for only in white light, but I'll work them up and send the image out. But this sun is very active. This group just grew from nothing. Big, strong, massive.
Yeah, we're just entering solar cycle. What is it? 17, I think. 25. I've got the numbers. I'm thinking back 10 years ago. Okay. Observing. Yes.
One time it was a clear early morning. My wife and I shot ticket for my wife to work. So I'm retired. I just drove and I saw a whole line of planets up.
In the morning
Really?
planets. Yes.
That was awesome. I see Jupiter, Mars, Venus, and one time Moon came out. And that's the only thing. I can't remember. Saturn was out there too.
Okay.
Jupiter, Saturn.
Anybody else?
We did the open house. We had the solar observers for the scout group. That was nice.
Did any of the scouts actually get to see sunspots?
I think so. There were spots. There were some active areas. There were prominences and filaments. Got to see everything.
Okay, great. Anybody online observing? Okay. Renew, it should say 2022 there, not 2021. But we are looking for people still to renew. We have about 20 stragglers at this point, 23 stragglers at this point, people who have not renewed from last year. We are going to have Starfest this year. Expect there to be a lot more happening this year than during a COVID year. At least as long as COVID stays down, we could stay up. Okay.
Hey, Dave,
Yes.
that was the wrong membership for chair listed. It's Craig Kaplan now, and it was still Bill on the slide.
Yeah, unfortunately, this slide is the slide that I did in previous year,
Yeah.
and I figured nothing changed and I didn't fix that.
Not
No, thank you for pointing it out.
It's Craig now, right?
Yeah.
It's Craig now, yes. Okay. May 11th, 7 to 9. We have a board meeting at the observatory. On May 15th, there is a lunar eclipse happening, and we hope to do that here too if things are clear. And that begins at 9:30. And Rochester Starfest, July 22nd, July 23rd. Now, Bob says something about an open house. When is the open house going to be for next month?
I don't know the date, that's.
Okay, stay tuned to the email for an open house in June. Late May or June, right?
You can send out an announcement when that's going to be. You can send that out to the membership.
Okay, that'll be cool.
Is our website up to date?
No.
I agree.
All right, so that's another thing we got to fix.
Keep that up current, I mean, especially open houses.
Yeah, no, I agree. Unfortunately, we're a volunteer organization and things fall behind, and we are always in need of new volunteers. If you feel like you could volunteer for something, please let me or Mark know, because we can always use help. For instance, we have a scout troop coming tomorrow. Explorer Scouts. And if you've never worked with scouts or done any outreach like that, you'll find it's a lot of fun. All right. Supernova 2022 HRS sitting beside M60 right now. This guy is a mag 12.5, which means it's easily gettable in a 6-inch telescope. Okay. And it's probably going to last a couple more weeks. Right now it's blue. Within a few days, it will start to turn red as it goes into its nickel phase. This is a type 1A supernova. Type 1As start out blue. They get brighter and brighter and brighter blue, and then they slowly change color to red, and then they dim down. I wouldn't say this is a dwarf, because if you take a look at the brightness of that object and you compare that to the galaxy that it's in, you'll find out that they're about the same brightness. So right now, that single star is just about as bright as that galaxy is.
Wow.
That's how much energy it's putting out. All right.
Can you remind me where M60 is?
M60 is in Virgo.
Okay, yeah.
So the supernova was in M60 or it's near? I'm sorry.
M60 is the orange thing.
Oh, got it.
NGC 4 something 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 is the blue thing.
So is it in?
It is actually in the NGC galaxy, which is a foreground galaxy to M60. But if you look at them in a telescope, this is what you'll see.
You said a 6-inch?
A 6-inch, you'll be able to find this, yes. Okay. We are cooking with gas. Do you guys need a break, or do you want me to jump right into the show? Keep going. Okay. I'm going to hit the escape bar here. And I am going to somehow move this guy down so I can iconize him.
There's a lot of people in chat. Yep. 18 people. There's like 10, is that 10? 11?
All right. The way this talk works is I start from the ground and I work my way up. And by starting from the ground, I need meteorite activity. On October 3rd, Ruth Hamilton was sleeping in her bed. She went to bed at 10 o'clock. And at 11:35, this thing came through her roof, down through the second story, and landed on the left side of the bed. She was sleeping on the right. Or sorry, other way around. She was sleeping on the left. The weird thing about this is that it works out to about 10 years to the day since her husband died, who was the guy that used to sleep there, that this happened. It came out to be about it came out to be about 2.8 pounds. This is called a hammerstone. And the estimated price on this thing is an eighth of $1,000,000. Every year I look for one of these interesting meteorite strikes. And every year since I've been doing this talk, there's always been at least one. Check out this. This is the Enigma Diamond. This is a 555.5 carat black diamond, recently sold at Sotheby's for an undisclosed amount. This is the largest diamond ever found. Before they sold it, they analyzed it, and it turns out to contain high concentrations of iridium and other chemicals that are typically formed only in space. Okay, Kelt Observatory on March 11th spotted this guy. 3 minutes later, it re-entered the atmosphere over Iceland. This is the 5th time that we've actually caught an asteroid in space just before it re-entered. Don't worry, it wasn't big. This thing is about 20 meters wide. Here we have the cargo ship Ever Given on March 23rd, wedged in the Suez Canal. This, by the way, is a shot from a brand new Turkish satellite. See all those beautiful little lines of this image? Those are ships waiting to unload at Long Beach, California. Now I'm going to give you a quote from my supervisor at General Electric telling me that just-in-time shipping was a wonderful thing. The Anatov AN-225, the largest cargo aircraft ever built and the thing that carried around the Russian space shuttle, destroyed by Russian shells. Yeah, and you see a destroyed Russian tank right there. This is the Zaporizhzhia, and if you're Ukrainian, I'm sorry, but I just butchered that name very badly, nuclear facility in southern Ukraine. You will notice 6 nuclear reactors. That plus the heat exchange unit gives a total output of this thing of 1 gigawatt of power. Ukrainians and the Russians thought this is a critical piece of infrastructure. So the Ukrainians figured they'd fight around it. The Russians shelled it anyway. If you see the white dot in the upper right-hand corner, that's where one of the shells hit. And that is the transformer for reactor number 6. Another one, see where the yellow dot is, just in front of the yellow dot? That's where another shell hit. And you see the other 3 shell hits here. The yellow dot was a security camera. Now, if you notice the white dot over the first reactor, if that shell had landed there, then last month they would have had to evacuate the city of Istanbul in Turkey. Yes, this is the largest nuclear reactor in all of Europe, and the Russians shelled it. Now, how many people knew about that? When you talk about a close call. When the Russians scrammed their reactor, this is what happened to the nation of Ukraine. You see Moscow on the top and Istanbul on the bottom. It went out. That was the major source of power for the nation of Ukraine. That whole big black thing is the nation of Ukraine after they turned off that reactor. Yes. They have done some work on it. Right now, the Russians are trying to get the reactors back online, but only for the Russian areas, the Russian occupied areas. And they've succeeded in getting 2 of the 6 reactors back up and running. But the people at, I'm not going to try to pronounce the name again because I'm just going to butcher it again. The people that control the reactor did an emergency scram on all 6 reactors while they were being shelled by the Russians. All right. Last year, I showed you a heat map of the Arctic. This is a heat map of the Antarctic. Notice the bright red patch over top of the eastern Antarctic ice sheet. This has never happened before. This is a 70-degree heat rise on the East Antarctic ice sheet. 7D. Take a look. For the first time ever on that ice sheet, people were able to walk outside without flesh freezing when they did walk outside. It has never gotten that warm before on the ice sheet. And here's 10 years worth of heat data. And remember, it's going into wintertime down there now. The effect that this has had on the Conger ice sheet is pretty dramatic. The Conger ice sheet literally fell off Antarctica and into the Arctic Ocean. Now, the Conger ice sheet isn't a giant ice sheet, but if the Ross ice sheet on the other side did, we're talking meters of rise in sea level. The island of La Palma after the December 25th eruption. The undersea volcano Tonga exploded on January 15th. And I've got a video of this I'll show you guys later. This is what it looks like now. If you take a look at the 2 objects on either end, those were 2 individual islands before this explosion. Category 5, Hurricane Ida from the International Space Station. Yeah, Ida stayed out to sea. This is the first shot of Landsat 9 over Nepal. We have a new deep space network antenna. This is DSS 53 in Madrid. That puts 5 antennas in Madrid, 3 in North Carolina, and 3 in Canberra, Austria for the Deep Space Network. The Deep Space Network is what is used to talk to our probes out in space. This is LOFAR in Norway. The LOFAR radio telescope was actually used to look at lightning. And it was the one that found that lightning originates from the clouds and goes down. The FAST dish in China is being used to observe fast radio bursts. And these are fast bursts of radio waves with about the power of a cell phone transmitter that are actually being transmitted from other galaxies, like chirps in radio. Some of them lasting milliseconds, some of them lasting as long as a second.
What's the size of that?
The FAST is about 2.5 times the size of Arecibo.
Is that located, Dave?
It's in China, about as far away from any city as they could possibly get it. Yes. This is what happens when you try to detect meteors coming in these days in England. Dotted lines are airplanes. The solid lines are satellites. Things are getting busy up there. Okay, launches. This is an NRO launch that happened on June 20th, 2021 from pad 0B at Willop Island in Virginia. This, you notice the stuff that's peeling off it as it rises? This is actually a Minotaur 1 or Minuteman rocket, originally assembled in 1966 and demothballed so that they could launch stuff into orbit. The Russians now have a moratorium on Russian engines. And it turns out that lots of our spacecraft use Russian engines. The Artemis moon vehicle. You'll notice some very similarities here to the space shuttle, and particularly the solid rocket boosters on the side and the orange center section. It actually uses space shuttle engines. They rolled it out to the pad with the idea of launching this thing to the moon, going around the moon and coming back. But as they were fueling it, they found a fuel leak. So now it's rolling back into the hangar where they're going to take it apart again. This is the launch of the Ariane 5 from French Guiana with the largest payload ever sent into geosynchronous orbit. Spin launch. This is a really cool idea. You take a little projector, you get it spinning really, really, really fast, and then you let it go. This is in New Mexico. This one can only do suborbital, but they hope to get a bigger one put together. Yeah, it gets spinning really, really, really fast around, and then they let it go. Supersonic. Don't need it. It'd have to reach orbital velocity to do it. And in fact, it'd have to go faster than orbital velocity because it's on the ground. So it'd have to overcome the resistance of the atmosphere to actually get into orbit. This is real, but this is just a trial. They haven't got, this is suborbital at this point.
You think they'll be able to put people in space?
Just the centrifugal force alone at about 20 Gs. You got to realize that if you take two cars at 60 miles an hour and you smash them together, you get an equivalent of 20 Gs, which is essentially equivalent to the surface gravity on Jupiter. It would not be healthy. No, this would not be recommended. No. Okay.
How much heat shielding does that thing need to expect it to reach?
They didn't talk about that. The only thing they talked about in the article, and by the way, I've got a link to all these images that I will give you guys online afterwards. Currently, the projectiles are about 1.5 feet long, and they're made out of solid steel. So they did launch the thing, because I didn't hear that it actually launched it. Yeah. So we will see how this works. All right, Virgin Galactic, Spaceship 2, July 11th, 2021. Richard Branson finally gets his trip into suborbital space. And here we have Richard Branson upside down in space. Not to be outdone weeks later, Blue Origin, New Shepard, with Jeff Bezos on board, launched. And here we have Jeff Bezos in space. And they plan on making this a regular thing. So they decided to launch Bill Shatner. And Bill Shatner came back down and he said, "The Earth is indeed round. I have checked." 90. 90 years old, and they put him on a rocket ship. He definitely volunteered. Captain of the USS Enterprise.
And he also mentioned he wants to make a movie out of it because he can feel it. Now he knows what he's looking at. he has to tell the writer this.
Yeah.
To produce a movie, make it realistic.
Well, I got to keep going here. Inspiration 4. Here we have the launch of 4 tourists into space. And here we have them. SpaceX does things a lot better than the other billionaires do. This thing actually went up into an orbit, which is actually higher than the orbit of the space station. What they did was they took out the airlock that connects to ISS and they replaced it with this giant cupola, so that the crew could look out onto Earth. They said that they loved the entire thing, except for one thing, the toilet backed up. Here's the Inspiration 4 crew landing. SpaceX put out a new barge for landing their spacecraft on in the Atlantic. This one is called Shortfall of Gravitas. So we can now decode how Elon is naming these things. It turns out they come from a series of books by Ian Banks called the Culture Novels. And it turns out that in the Culture Novels, there's a starship called A Shortfall of Gravitas, another one called Of Course I Still Love You, and another one called Please Read the Instructions. And those are indeed the names of his barges. He had to do this because now he's going to be launching one SpaceX rocket, SpaceX Falcon 9 rocket per week from Canaveral and one every 2 weeks from Vandenberg Air Force Base. So in order to get the throughput on the number of rockets he's launching, he needs the extra barge. This is a batch of another 47 Starlink satellites launched on March 3rd, 2022 with booster serial number 1051. And this just happens to be the 12th launch of this particular booster rocket up into space, up and back down again. They land, they tow them back, they refurbish them, and they launch them again within just a few weeks. Here, oh, I'm going to show you a cool video soon. Yes. This is Falcon Heavy booster rocket left being shipped to the rocket garden at Canaveral. The Falcon Heavy booster right is going into the rotation for the regular Falcon 9s, and they're building a brand new Falcon 9 Heavy from the ground up with new side boosters and core boosters. And I'll show you the animation for that later. Here we have a shot taken from the International Space Station of a Falcon 9 aimed right at him. Crewed Falcon 9. And here we have the Axiom space mission, which is the first fully commercial launch of the Falcon crew with the Space Launch System sitting in the background. It turns out that SpaceX is only going to build 4 Falcon 9 crews. 1 docked to the space station, 1 sitting on the launch pad, 1 being refurbished, and 1 is a spare. And they're saying that until Starship is ready, that's all they'll ever need. Here we have the Axiom mission docked to the ISS. First private space flight to ISS, 4 crew members aboard. The Axiom guys have really big ideas on building space stations. Here's the latest shot of the ISS. You will notice the brand new solar arrays. These were shipped up on a Falcon 9 and were deployed on ISS to supplement the older and aging solar arrays. Yeah, they're the smaller ones in front. Okay. The overview effect. And yes, that is exactly where we live, right on the right side there. Here we have a Falcon 9 leaving the International Space Station. This is one of the latest Falcon crews. They can carry up to 7 people in these things. And typically they do only 4 at a time. The way the spacesuits work is the spacesuit is integrated into the seat. So you can just unplug yourself and plug yourself in to your seat, and your seat can give you more oxygen and whatever else you need. This is the new Russian space station segment called Nukia. Nukia was originally planned for launch in 2007, and it just got launched this last year. According to the Russians on board, it's already starting to crack. Added to that on top, you'll see right there is the Prichyia module. The Prichyia module adds 4 more Soyuz docking ports to the ISS. Here we have Soyuz MS-18-64S on docking from the space station, that being the 64th Russian cargo module to go up and down from ISS. And Dexter, the robotic arm that was shipped up last year. Here we have the Chinese space station. The 3 people on board the Chinese space station have just left it and gone back down to Earth. So it's currently uncrewed. They docked on June 17th. And like I said, they just recently came back down again after spending 2 crews, spending 6 months up there. It's called Tianhe, Tianhe. And Tianhe in its final configuration, which will look like this, will take about 10 launches to create. I do not know why they left it uncrewed, but I'm told that it's a temporary thing, that they're going to be sending up another crew to it. The seat's up here, guys. This is the launch of Shenzhen 21 on October 2021 on the Long March 3B rocket. This thing did something really cool. It went into geosynchronous orbit, grabbed a defunct Chinese geosynchronous satellite, and moved it into a new orbit. We did not know the Chinese had the technology to do that. No, I doubt it, because it's functional now. The 1980s computer aboard the Hubble Space Telescope got into fault mode last year. For about 3 months, the telescope was dead. But what they finally did is they finally figured out how to get it back up and alive. So HST is back up and running. And it was joined just recently by IXPE. Devin, thank you so much for bringing this water. This was launched in December 9th of 2021 and is indeed an X-ray space telescope. Chandra. And of course, the James Webb Space Telescope. Now I have a video I'm going to show you later of the deployment of the James Webb Space Telescope, but we'll go through it in slides really quick. Here we have it finally making it to the launch site and the launch of James Webb Space Telescope aboard an Ariane 5. It got out to L2, it slowly unfolded itself. And once it got into L2, it went into a commissioning phase. And for those of you who want to look deeper at these slides, they will be online. I'll send out the link to the web, to the reflector, so that anybody who wants to go into them can do so. every single slide in this is linked to the article it came from. So there's no question about the attribution on these slides. Here we have our first image from the James Webb Space Telescope. The mirrors aren't aligned yet, so this is all one star. Once they got it aligned, things look just a little bit better. Now, just to give you an idea, this is a really, really, really faint star. See the green arrow on the side? It turns out that there's another probe called the Geoprobe out at L2. And it took a shot of James Webb as it passed by. Now, this is the orbit of the James Webb Space Telescope, and I'm going to talk more about Lagrange points later. The L1 position is the position between the Earth and the Sun. And L1 is a stable gravitational node. The problem with it is the Sun overwhelms the signal from anything at that location. So what they do is they do a figure eight through it. L2 is the counter Earth position, where you're in orbit around both the Earth and the Sun at the same time. That's another node, which is a little less stable than the other Lagrange points. And what we're doing with James Webb and with Gia is it's orbiting that spot in space. Lagrange 3 is the anti-Earth position on the far side of the Sun, basically counterbalancing the Earth's position. And L4 and L5 are also two stable nodes. And it turns out that L4 and L5 are very interesting positions. This is the south pole of the moon, Atkins crater, which turns out to be a very, very old impact crater, 2,500 kilometers wide. LRO, the Lunar Reconnaissance Orbiter, spotted this. And what this turns out to be is when they launched Apollo 16, they aimed its booster rocket at the moon. And it indeed hit the moon. And if you take a look at the shape of that thing, that's the shape of an Apollo booster rocket. Discovered on March 10th. You have the path of the Chinese lunar lander on the far side of the moon. It's still trundling about and has been for the last couple of years now. It's finding lots of these things. What these are is these are little glass beads. And it turns out that when an impact hits the moon, it vaporizes some of the sand. The vapor collects into little glass balls and actually freezes into the ball before it lands on the surface of the moon because the moon's gravity is so weak. They got excited when they saw this. And what this is this is a very distant image, and it was called the Great Mysterious Hut. So they decided to move closer to it, and that's what it looks like close up. It's a rock. It just happens to be sitting on the edge of a crater. After 50 years, they decided to open up one of the Apollo samples and analyze it. This core was especially preserved for this purpose because it was thought that 50 years later, the technology would be much better. This is just started, and they've just started the analysis of this core. Lagrange points again. L1, L2, and L3 I told you about. And I told you that L4 and L5 are interesting positions. It turns out that we have a companion moon. Earth has a Trojan named 2020 XL5 that orbits at the L4 position. This thing is about 1.2 kilometers wide, and it can actually be considered a moon of the Earth out at the L4 position. There's another asteroid also discovered orbiting L4 called 2010 TK7, but it's a little bitty thing, just a few meters wide. And this doesn't show up very well. How does it show up on the screen?
It's kind of dark, but it does show up.
Okay. This is asteroid 2022 ES3, about 22 meters wide. This thing passed between the Earth and the Moon on March 13th. The sun. On January 30th, 2022, there was a massive X-class flare on the far side of the sun, pointed directly away from us. The only reason we knew about it was because of the probes that we have called the exosun, I believe, probes. Oh, why can't I remember the name of it? I didn't write it down. The Parker Solar Probe, which is a name I do remember, is exploring the sun and is now getting very close to the sun, exploring the sun's outer corona. And it is getting very hot. Here we have a shot of Mercury from the probe called Bipepy-Combo. Bipepy-Combo is doing its first swing around Mercury. And it's going to do one more around Venus and then one more around Mercury and do a Mercury orbital insertion. And this is something I didn't know, but got recently published. Mercury has a tail. And the tail is actually made out of sodium ions. I did not know that. Tectonic plates on Venus. It appears to have some live tectonic faults. This is from the Akatsuki probe around Venus. This is a shot from ExoMars. ExoMars is a gas trace or observer orbiting around Mars. And this is a shot of Valles Marineris. And it turns out that there is a significant ice deposit on the bottom of Valles Marineris. The Curiosity rover, Mount Massaro. Curiosity is finding these things. This is about the size of a penny on the surface of Mars. When they first looked at it, it looked an awful lot like a coral outcrop. But it turns out that what it is it's a mineral incursion into a strata that has since worn away. The path of the Perseverance rover. This is Scrape A, Jezero crater. Kodiak Mount, Jezero crater. The helicopter called Ingenuity has been very useful as a scout for the rover. And what they're doing is they're sending it around to take pictures of where the rover is going. Here we have a picture taken from the Scout, and you see its shadow down below. There's a rock stuck in the wheel of Perseverance. And Perseverance is a microphone, and it makes a wonderful noise as it moves. This is what an eclipse looks like on Mars. This being the moon Phobos. And here we have a shot taken by the Ingenuity helicopter of the back shell of the Perseverance rover. This is what things look like when they impact the surface of Mars at 200 kph. Here we have the landing site of the Chinese rover, Zhongrong. Here's a shot from the rover of the back shell, of course. And here's a shot of the orbiter. It's really cool how they got this shot. What they basically did is they put a webcam on a tether and let it go. And it just kept on filming until it got a decent shot, and then they reeled it in and downloaded it. Okay, our next step out. This is Comet Bernardini Bernstein, C2014 UN 271. How many people remember Hale-Bopp? Hale-Bopp was 30 to 40 kilometers in size, which is huge for a comet. This thing is 100 to 200 kilometers in size. It's due to pass 11 astronomical units from the sun in the year 2030. So this could be a truly spectacular sight if it burst. We'll see how it does. This is our bright comet from last year, Comet Leonard, passing between NGC 4631 and 4656. And this is a concept of the DART mission. The DART mission is flying into space, hit Dimorpheus, which is a satellite of Didymos. And what they're going to do is they're going to fly this thing right into it in a hopes of changing the orbit of Dimorpheus around Didymos. And they've got a little CubeSat they're going to leave behind to observe the impact. Also launched this year is the Lucy mission. The Lucy mission is designed to look at Jupiter's Trojan asteroids. Jupiter has Lagrange points too, and its Lagrange points are full of interesting things. So it's going to be launched from Earth, go out to Jupiter's L4, observe as many as it can, come back to Earth, and then go out to L5. Jupiter's L5, not the Earth's L5. Okay, our next step out. On September 13th, something hit the surface of Jupiter. This has been observed twice before, where we've seen flashes on the surface of Jupiter. But this year we didn't observe not one, but two flashes on Jupiter. This one was observed on October 15th and was seen by observers both in Japan and Brazil. The Juno probe is digging into the Great Red Spot and observing it very closely. And here we have a map showing how deep the storm goes. And it turns out that the Great Red Spot goes 500 kilometers deep under the cloud deck of Jupiter. Now they're expanding Juno's orbit to actually include the moons of Jupiter. And this is Ganymede. A new shot of the outer planets by the Hubble Space Telescope. Neptune is cooling. Neptune has dropped 8 degrees Celsius over the past 17 years. Our current list of dwarf planets, the only thing really new on this is that some of them have now been named. And the shapes of some of them have been a little better figured out. Here we have a plot of 5,000 exoplanets. And you will notice the test field of view on the left-hand side. The larger the circle, the larger the exoplanet. It turns out that now we have 10,000 plus exoplanets that have been discovered by various methods. One of the latest and coolest ones is Kepler 1708. Kepler 1708 has a moon, which is 2.6 times the size of the Earth. And this is orbiting a star 5,000 light years away. Stepping out further, this is Z Canis Major. 2 red dwarfs that came much too close for comfort. This is an object called a magnetar, some 4,000 light years away. This thing is beaming out radio signals every 18 minutes. HH 666 and Carina, a dust pillar from the Hubble Space Telescope. And our latest map of our home. Here's where we live in the Milky Way galaxy. You'll notice that we're sitting right in the center on the Orion arm. Let's see if this thing works. Oops, that was a very bad thing to do, David. All right. I've learned my lesson.
My home, I didn't even present. I said, use this data, it'll be great.
As was said by, I believe, a poet by the name of Ed Green, the best laid plans of mice and men aft gag a flag. Okay, here we go. I wish I could zoom in on this because this is an extremely busy image. But what this shows us is this shows us where we are in the galaxy and all the directions of where all the cool stuff that we look at, like M16 or the Cygnus arm or where everything else is. I will send you guys a link. What they've discovered, and this is a not so busy slide of the same exact thing, is that there are feathers of dust that are somehow connecting the arms together. Here we have the core of our galaxy in radio waves. Gravity waves. These are 90 gravity wave observations, which is the number that we found so far. Now remember, it was just 3 years ago that the first one was discovered. NGC 4676, also known as the mice. APR 195, Hubble shot. A new kind of supernova was declared this year, a type 1CN supernova. The difference between this kind and the other kinds of supernova, and there's no hydrogen and no helium in this particular type of supernova. This has never happened before. 3 supernova at the same time in the same galaxy. We've had 2 before, but 3 has never happened. Now remember, in a galaxy that's our size, you're expected to see 1 every century. This is the famous ring galaxy, taken by one of the guys who contributes to my webpage. This is a supernova called 2021 AFDX in the ring galaxy. If you look up the ring galaxy, it's a very famous Hubble shot. Here we have some galactic lensing. This one looks particularly weird. You will notice the long outstretched galaxy that's behind that galactic foreground cluster. Galactic lenses look like very, very imperfect optical lenses. Like you take an optical lens and you smush it. and you get these really weird distorted effects. Here's a whole bunch of lensed galaxies that are behind a couple of galactic clusters. And you can tell there's a galaxy there, and you can tell there are multiple copies of the same galaxy if you look at it closely, but you can't really see a lot of detail because it's just extremely imperfect lens. But it turns out we got lucky. If you'll take a look at the bottom right of this image, you will notice this little structure. And what this little structure is this is actually an optically correct lensed star in a galaxy behind this cluster of galaxies. And this is a single star, just optically lensed by the gravity, and then of course lensed by our own telescopes. So we can actually see an individual star in a very, very, very distant galaxy. And that is my last shot. That one, by the way, was a meteor that came in over Norway. And that was one of the slides I had to take out because this thing was getting too big. All right. Any questions on those slides before I get into the movies?
Martin says, very nice job, Dave.
All right. In that case, the Tonga explosion. Now I have this hooked up to the audio in the room. And you guys online should be able to hear this because I'm pretty sure we debugged this before you came on. Remember, all these slides and all these videos, this is just from the last year. The OSIRIS-REx mission is currently on its way back to Earth. And last year I told you about the sample that it took. In the interim, they released when it gets back to Earth, they will analyze the samples. Don't worry, you will see the James Webb Space Telescope. How many people watch Astronomy Picture of the Day? Every day. So do I. And every now and then, they give us what I will be doing is I'll be sending out an email with a link to all the videos. All right, one more video, and then we will call it a meeting. And I can go on for these videos for hours, guys, so. Because I just love watching them.
As the sun rises over the Guiana Space Center, the team conducts final checks on the health and status of the Ariane 5 rocket and its payload. The James Webb Space Telescope, NASA's #1 science priority. Webb telescope is designed to look back to a time when stars and galaxies were first forming, over 13.5 billion years ago. With its revolutionary design and capabilities, the Webb telescope is about to unleash a new dawn of discovery.
À tous de vidéo, attention pour le décompte final. 10, 9, 8.
Seconds before liftoff, the Ariane 5's liquid-fueled engine comes to full power, followed by the ignition of the two solid rockets. We have liftoff. The Webb telescope is finally on its way, the result of years of study and development by thousands of team members in the United States, Canada, and Europe. Webb's spacecraft ascends nearly vertically through the heavy lower atmosphere of Earth. As the rocket reaches maximum acceleration, the spent solid rocket motors are jettisoned safely into the Atlantic Ocean. Reaching the upper atmosphere where protection is no longer needed, the payload fairing is jettisoned and falls away. Accelerating through the atmosphere, the Ariane 5 rocket's first stage expends its fuel and shuts down. The empty first stage then separates from the upper stage. After first stage separation and before second stage ignition, the Webb telescope has a slightly downward trajectory as it speeds over the Atlantic Ocean. The upper stage motor ignites and the ascent to L2 resumes, never again to be interrupted. The exposed telescope is delicate and must be protected from the sun's fierce heat. To avoid overheating and damage, a carefully designed series of oscillations are performed that provide the necessary protection. Near the end of powered flight, the roll program stops and the launcher then assumes the proper attitude for separation. After separation from the Ariane upper stage, the Webb telescope continues its journey to L2 under its own power, taking the next step to its final orbital station 1 million miles from Earth. The Webb telescope is about to unleash a new dawn of discovery. The Webb telescope separates from the launcher's second stage. The white ring close to the Earth represents the Hubble Space Telescope's orbit, and the larger orbit is the geosynchronous orbit where most telecommunications satellites are located. The solar array is Webb's first deployment. When completed, all of Webb's electrical power needs are satisfied by the solar array for the remainder of the mission. The onboard control system continually monitors and updates the attitude to ensure power generation and thermal safety. To preserve the cleanliness of the mirrors, thrusters are located only on the sunlit side of the observatory. The trajectory is designed without employing a retrofire, which necessitates pointing the delicate telescope at the sun. If course corrections are needed, these velocity additions must be done early in the flight to most efficiently use the mission's limited precious fuel. After completing mid-course corrections, the Webb telescope passes the orbit of the Moon. Webb's initial transformation is the deployment of the Sunshield pallets. cover separating the telescope and instruments from the spacecraft and Sunshield is next. Next, the aft flap deploys. This is key to managing momentum buildup and fuel consumption. This structure helps to balance the pressure from the sun's light on the Webb telescope around its center of mass. After the Sunshield pallets reach their final positions, the membrane launch restraints are released. These have kept the Sunshield membrane safely in place from final stowage at the Northrop Grumman facility in California through shipment and launch. The Sunshield protective covers roll back, permitting membrane deployment. The covers over the core region release next. Then the mid-booms extend and the Sunshield assumes its hexagonal tennis court-sized shape. It is now time to tension the Sunshield membranes, each thinner than a human hair, pulling each of the uniquely sized and shaped layers to their optimal position. When deployed, the Sunshield allows the telescope to cool to 385 degrees Fahrenheit below zero, cold enough to liquefy air, while the layer closest to the sun is almost 190 degrees Fahrenheit above zero, nearly the boiling point of water. It's of almost 600 degrees. Truly fire and ice. Once in the shadow of the deployed Sunshield, the telescope and instruments continue cooling down to their final operational cryogenic temperatures. At the completion of membrane tensioning, the secondary mirror deploys into position and is latched rigidly in place. The aft deployable radiator releases and springs into position, allowing the instruments to radiate their waste heat directly into space and away from the telescope. Disposing of excess heat is crucial to the mission so that it does not overwhelm the faint infrared signals to be collected from the cosmos. The cord-fold wings deploy and latch in place, completing the major deployments of the largest telescope in space. As the Webb telescope continues out to its operational orbit around the Sun-Earth L2, the observatory continues to cool down to its final cryogenic temperature state. A trajectory correction applied 29 days after launch puts the Webb telescope into its halo orbit, a key part of the mission design. The Sun-Earth L2 point is where Webb's orbit around the Sun is synchronized with Earth's. At this point, 1 million miles from Earth, Webb is free from the thermal influences of the Earth and all eclipses. Additionally, the Sun, Earth, and Moon, the brightest objects in the sky, are hidden by the deployed Sunshield, giving Webb a dark, cold, and stable environment to carry out its mission of discovery. Once the mirrors and detectors are sufficiently cold, the wavefront sensing and control operations can begin. This sophisticated multi-step operation's ultimate goal is to position each of the Webb telescope's movable mirrors into their correct final positions and orientations. Once the mirrors are aligned, the mission team will continue checking out the science instruments, preparing them for operations. Commissioning is completed about 160 days after launch, and the science mission is ready to begin. This brings to fruition the work of the thousands of members of the Webb team from the United States of America, Canada, and Europe. Astronomers from all over the world can now use this facility to study the universe. NASA's James Webb Space Telescope. is a game changer. Discoveries made by this observatory will rewrite textbooks, inspiring the next generation of future engineers and scientists. This revolutionary tool will provide an unprecedented view into the birth of the first stars and galaxies, unleashing a new dawn of discovery.
Okay. With that, I will take questions. Any questions? Hubble is about 150 some miles up in its orbit, and it's a fairly equatorial orbit. James Webb is way out there. It's a fairly low Earth orbit. I think it's 300 kilometers. Yes. Yeah. Any online questions?
I don't see any at the moment.
If we have anybody online,
Plenty of comments. Tony and Craig both said, thank you. Excellent presentation. Fabulous. It always is.
all right. So I take it I can open up my slideshow 2023 directly now? All right. Collecting more slides. I also promised you guys this one because somebody asked. Who was one that asked about Falcon Heavy? This is the new concept for Falcon Heavy, which is actually the new old. Well, imagine showing that image, showing that video to Werner von Braun. Imagine what he would have thought. SpaceX is doing amazing things. You'll notice that there are no images of Starship in this. And it's because Starship is still sitting on the pad, fully assembled, waiting for clearance to launch in Boca Raton, sorry, in Where is it in Texas? Boca Chica, Texas. The idea behind Starship is a fully reusable system. SpaceX is launching one SpaceX rocket per week now. When you launch something on the space shuttle, the equivalent price was about $100,000 per kilogram to orbit on the space shuttle. SpaceX has it down to $150, and they're getting it down to $56. Is their right? And they're getting it down. They want to get it down. SpaceX wants to get it down to $56 per pound into orbit. If they get SpaceX working, if they get Spaceship working or Starship working, and Starship works as planned, it will get down to $8 per kilogram into orbit. So, well, the cool thing about the way that the SpaceX Falcon 9s work is the Falcon 9s burn kerosene. Okay, which is your basic fossil fuel that we have on Earth. And we can actually make kerosene synthetically if we have to. The Merlin engines, which are what power the Starship, actually burn methane. And the reason why they burn methane is because methane can be manufactured on Mars, out of the Martian atmosphere. So the idea, you fly something to Mars that can manufacture methane, you land the rocket on Mars, you refuel it on Mars, and you send it home. No, Moxie is actually creating oxygen. Moxie is an experiment inside the Perseverance lander, and what it's doing is it's creating oxygen. Well, liquid oxygen would be a rocket fuel as well, but not methane. But that's what Moxie's doing.
Do they use the hydrazine red nitric acid anymore?
They still use that for orbital control. Believe it or not, what the new rockets are actually using is scuba gear. They're actually using scuba gear breathers and controlling them electronically with gas as their attitude control rockets.
That's a long way from the containers of 6,000 pounds of nitrogen gas.
Mm-hmm. Okay, how is the cave doing?
When you open the roof, oh, Roger, so we take the roof back, so it's still covered with the bench.
Okay, that's what I'm planning on doing anyway.
So the limit switch is-
Closing it is more critical because that limit switch is not working.
Okay,
You have to approach the end of the run, closing it extremely slowly.
that's what I always do anyway. I don't trust that limiter switch anyway.
Well, it doesn't work now, so don't trust it.
Okay.
So you have to-
For those who don't know, there is a scout troop here tomorrow that will be showing up at 11 o'clock. And they're going to be doing some work around the observatory. We have scout troops now scheduled pretty much throughout the summer here at the observatory. For those of you who don't know, the next meeting is also going to be here in June. And we're going to have some sort of a talk from the Buffalo group. I'm not sure who's going to do it either, but we know it's going to be from the Buffalo group. The Buffalo group about what? 2 months ago when we first met, you and me. When I did the Buffalo talk, how long ago was that now? September of last year. Well, anyways, they had an emergency call for a speaker, and I did this talk, the previous incantation of it for them. And I'm going to be doing it again for them next Friday.
That's how you came to our club for that meeting?
Yeah.
Oh, I didn't know that.
No, that was my first encounter with the Buffalo Club. All right. With that, if there's nothing in the chat, we will end the session.
Nope, that's it.
All right.
Everyone.
So we are gonna get all those videos and we.
Yes. In fact, what I